Mario Oliver. For my final presentation, I'm focusing on transmit beamforming. I know Jasmine just did it, but I tried to focus on other aspects of the code. And also on one of the examples that I did last time on MIMO RF receiver with a beamforming example. I tried to work on it, and I got a little bit of work done. This is my team, Alpha, 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 Beta. So for my overview, I'm gonna be talking about the beamforming with CSI versus spatial expansion, and then I'm also gonna be talking about the other example that I worked on from last time. So what is transmit beamforming and spatial expansion? So transmit beamforming is a technique used to transmit a signal from a number of antennas to multiple users. The beamforming in this case is uses a steering matrix that is calculated using channel state information. So the way it works is the channel state is obtained by sounding a channel between the beamformer and the beamforming, so the transmitter and the receiver. And then the beamforming uses that data that the channel state gave it to calculate a feedback matrix, and then it sends that feedback matrix to the beamformer, and the beamformer uses single value decomposition to turn this feedback matrix into a steering matrix. And after this steering matrix is created, it turns the beamformer towards the beamforming for better performance. And spatial expansion is a spatial mapping technique used to map fewer space times time streams to more numbers of transmitting antennas to obtain spatial diversity. It is worth noting that the number of spatial streams has to be equal to or less than the number of transmitters. Um, this is just an example of multiple antennas and just one spatial stream that I found. I was trying to look more into spatial expansion. And as you guys can see here, the red one is just an improved CSI that they did on their paper. But this is with regular methods, and more transmitters gave them a better result. But it was not as much as they would have wanted compared to the cost of having more transmitters. And right here, I have a 4x2 versus a 4x2x2. So basically, one with one spatial stream and one with two spatial streams. You guys can see right here that the one with two spatial streams has a lot more error than the other one. Right here, we can see the SNR and then also the error magnitude. Like right here, you guys can see it at for the one that only has one spatial stream, it has 13.9% for when you use spatial expansion, and 5.7 error when you use beamforming. Whereas compared to the one with two spatial streams, it has 55 and 71 for the spatial expansion. So you can tell that it's much worse than with one spatial stream. So what does it mean? It means that the receiver can be a beamforming, and if the receiver can be a beamforming, you can improve its SNR when it is beamformed compared to spatial expansion. And the increasing power can also make the demodulation more reliable, and it can lead to a higher order modulation in coding schemes. It is important to note that beamformers would change in a real scenario due to the delay of channel state information and feedback from the receiver. And right here, this was another part of the code where you can choose whatever equalizer. I wanted to test equalizer MMSE versus zero forcing. And on the first picture, you guys can see the one for MMSE. It's it's expected to be better than zero forcing, but I would have thought it was a bigger difference, but it's only from like 44 to like 50, or like it's the same basically for beamforming. And right here, the the code that they're using is VHT, so it's a very high throughput, which means that it allows us to simulate 8x8 antennas. Um, and this is basically where we get the results. It's a very low error magnitude, and also the SNR is better. This is the example that I kind of touched on last time. I couldn't uh, get into it last time because I didn't know how to like download it, but this time I went into it and I tried messing around with it, and I saw um, the the angle on the left when it's at 90 degrees. It's basically the transmitter is facing the receiver, and then when you move it, let's say to 60, um, basically like the graph on the right is when you move it, you can see that it's all scattered up, and the one on the left is the original when the transmitter is facing the receiver. I think this will be like an example of like analog beamforming, but I'm not positive. Um, some I know there's no more labs or I mean presentations, but some of future work that I could have done with this is having more users on the code for the transmit beamformer versus spatial expansion. I tried to work on it. I saw the pre-coding example that Jasmine was using. It had multiple users, but I couldn't implement it into this one. I kept getting errors. Another one is just to learn more about CSI and how it helps how like for example the example with spatial expansion was had a better CSI method than the regular one, and also how to figure out how this blocks works. And these are my sources.